Hey guys, welcome back to the channel. In our previous class, we have learned about the super keyword, constructor chaining and generalization. In our today's class, we are going to learn about typecasting. Conversion of data from one to another is known as a typecasting. Typecasting means conversion of variables from one data type to another data type, or the value converting it from the larger data types to the smaller data types, or from the smaller data types to the larger data types, is called as a typecasting. When the value is being converted from the larger data type to the smaller data type, some value might be lost. When you assign the value of one type to another, the two types might not be compatible with each other. If the data types are compatible, then Java will perform the automatic conversion, and if they are not compatible, then you have to convert it explicitly. Now let us see it with some example for the easy understanding. So here you have typecasting. There are two types of typecasting. So one is a primitive casting and another one is a non-primitive casting. Now what is this primitive casting? So if you see, there are two types of data types. One is primitive data type and one is non-primitive data type. About the primitive and non-primitive data type, I will put the link of this video in the description as well as in the card. Now first, what are the primitive data types? Integer, float, long, char, etc. are the primitive data types. And what are non-primitive data types? Like a string, class. So these are etc. are some non-primitive data types. Now here, when you're going to convert the primitive data types, you have two things. One is data widening and data narrowing. And when you're going to convert the non-primitive data types, you have upcasting and downcasting. So let us understand these in more detail. Now you can see some rule here. So what is this rule? If LHS is greater than or equal to the RHS, then you need to follow this rule. If the LHS is smaller than the RHS, then you need to follow this rule. You will understand that. Now, let us see what is data widening first. It is a process of converting a lower data type to the higher data types. Now here you can see below there are certain data types. Now, what are these data types? Byte, short, int, long, float and double. So this is the lowest data type and this is the highest data type. Now if you want to add the byte size to the double, you can add it easily without any effort. Now if I'm going to give int I is equals to 20. Now this 20 is an integer. Now the same 20, if I am going to convert it to long, if I am going to give long I is equals to 20, then this is also right. It is not going to give you any sort of error because the LHS that is there, that is greater than the RHS, or the LHS is equal to the RHS. So this is the first rule that we have seen, that is for data widening. So this rule, always remember, for data widening, if LHS is greater than RHS, then there is no problem in conversion. There is no problem in conversion. There is automatic conversion of data type. Now let us see that with data narrowing, how it works. Now, data narrowing is a process of converting the higher data type to the lower data type. So this is the highest data type you have and this is the lowest data type you have. Now, if I have int I is equals to 120 and if I want to convert this int to the byte, now int is having greater sizes whereas your byte is having smaller sizes, correct? Now byte means 1 byte. 1 bit, 8 bits is equals to 1 byte, whereas your integer is greater than that. 4 bytes is equals to 1 integer. It is going to take 4 bytes. So 8 bit is very less than 4 bytes, right? So byte b is equals to I. If you're going to convert it like this, then type mismatch cannot convert from into byte. So then you have to tell, hey compiler, so we have one thing that is byte b and you need to convert your I into the byte size. Here you have to add one more LHS, that is byte. You need to add your left hand side content to your right hand side. So why it is going to tell? It is going to tell the compiler that it has to convert it to I. And here there might be some chances of losing the data. If this is greater, if this has a greater value, then there are the chances of losing the data. So this is usually not used. Next is, now this rule comes into existence. LHS, if the LHS is equal to or greater than the RHS, then you need to add an LHS content here inside your RHS. Now int I is equals to 31200, byte B is equals to, hey compiler, convert this I integer value inside this byte. So rule is correct, but it leads to data overflow. That is, some sort of data might get lost. Next is a non-primitive casting. Here you have upcasting and downcasting. So let us see the first, upcasting. A superclass reference referring to any of its subclass object is called as upcasting. That is, reference is from superclass and object is from the subclass. Now reference will be from the superclass, whereas the object creation will be from the subclass. Now if you're going to see, you'll be having a superclass, a fruit. And inside this fruit, think that there are three subclasses. One is apple, one is a mango, and one is kiwi. So you have three subclasses here. Now if you want to create an object of the subclass, you can also use the superclass reference. That is called as upcasting. Fruit F is equals to new apple. Now here also same thing. Engineer, you have multiple streams of engineer. You have used the superclass reference to create a subclass object. Same for these two as well. So let us see an example for upcasting now. Okay, so we have seen this example somewhere. Where? In the overriding method. In the overriding, we have seen this example of an engineer and the work, right? So I'll be linking the overriding link in the description as well as in the card. And here this program can be taken by you guys and you can work on it and you can see the output on your own. I'll be explaining this here. Engineer E is a superclass with some child classes as software engineer, electrical engineer, civil engineer. So these are some child classes and all have the work method. Here it is overridden, here it is overridden, here also it is overridden. Now, whenever I want the output of software engineer, what I have done, usually we take a software engineer, we take it like this. Software engineer E is equals to new software engineer. So what we have done here, a slight difference, that is, we have taken the superclass reference to create an object of our subclass. This is also a right thing, which is called as upcast. So now this example is showing you the concept of inheritance, upcasting as well as overriding. Now same rule applies for the downcasting. So it is the converting a superclass type into the subclass type is called as specialization. Now there is a father, I can explain this in a real smooth way. Father, son. Now the father can easily tell that this is a son, and by the help of the father class you can create an new object of the son class. That is, a father can create multiple sons. But can a son create a father? No, a son cannot create a father. So let us see it with an example. Now here you can see class father, that is the superclass, and work, the child class except father, void play, enjoying son, and here you have. Now the father can create a new son. So this is what? Upcasting. If you want to create downcasting, then you are going to write something like this. So this is downcasting. If you are going to write it as son is equals to son dot father, and if you are going to use son dot works, then it is going to work well here. If you are not going to use this, or if you are just going to use a father dot works, that also will be fine, but it is not downcasting. Whenever you are going to use this downcasting, you need to use the LHS again in the right hand side. And this also you're gonna try it on your own and give your feedbacks in the comment section. This is all for today's video. For the next videos of Java, stay tuned. Bye bye.